Okay, so on last semester we talked about congruency. Let me just refresh our mind. Remember, congruent was a shape that looked like this. And I used to say that this wiggly thing on top, this thing basically represented same shape. And this equal thing on the bottom basically said same size. You guys remember this? Okay, we had two figures and we call that congruency or congruent. The figures were congruent. Now, same shape. Obviously, we had to compare triangles with triangles. We had to compare line segments with line segments. The shapes had to be the same shape. And then they had to be the same size. Now, for this unit, like I said, that was before. For this unit, let me take out the same size part, and I'm going to talk about figures that have the same shape, not necessarily the same size. Now, imagine you guys, you take a picture of yourself. Let's say you take a selfie. Boom, you come over and take your selfie. Now, the picture on your phone looks like you, right? However, picture on your phone has the same shape, but not the same size, right? On the phone, the size is smaller than your actual size. That is what we're going to be talking about. Figures that have the same shape, but not necessarily the same size. And we're going to call those similar. Now, there's two things that similar figures must have. So two criteria that have to be met. Criteria number one, if there are any angles, right? Well, there are angles on all the figures except circles. But on all the angles, we're going to say the angles have to be the same. So let me just say it, same angles. So when we're talking about angles in the figures, they must be the same in order for the figures to be the same shape. The second criteria, because I said there's two criterias, when it comes to the sides, now the sides are not going to be the same because otherwise we'll be saying congruent instead of similar. When it comes to the sides, we're going to say the sides are proportional. Proportional. Okay, what does that mean? Okay, we'll talk about that in a minute. For right now, let's just call it proportional, okay? So in order for figures to be similar, they must have the same angles and the sides must be proportional, okay? So let's take a look. Let me remind you guys how to solve for a variable when there's two fractions. We call that proportion. Wait a minute, Mr. Leon. So you said proportional earlier, and this is proportion? Exactly. Let me talk about questions 1 and 2 for right now. This is a review of what you guys saw in algebra when we have to solve for a variable and there's two fractions equal each other. Remember, we used to say, let me just cross multiply. So I used to just come in algebra, we used to do 3 times n. Keep in mind, I'm multiplying 3 times n, we just call it 3n. This is equal to 8 times 6, and we call that 48. And then to get the n by itself, we will divide by 3. It's the number in front of n, because 3 divided by 3 is 1, 1n. I'm just going to write the letter n. 48 divided by 3 is 16. Okay, again, questions number 1 and 2 are review. You guys should have seen this before. You guys saw this in algebra. But we'll practice a little of our review. It says run to the nearest hundredth if necessary. Okay, so if I have decimals, run it to the nearest hundredth. Now 100 sounds like the number 100. It's a 1 with 2 zeros. Because there's 2 zeros, then 2 decimal places if necessary. Question number 1, I didn't need to do decimals, so I just said n is equal to 16. Now let's take a look at question number 2. I'm going to cross multiplied. Now, in this case, because there's a plus or minus, sometimes it's a minus, sometimes it's a plus sign. When there's a plus or minus, that's 7. The number that is by itself has to multiply to m, and it has to multiply to 1. So I'm gonna get 7m plus 7. Remember, I went 7 times m and then 7 times 1. That's 7. The number by itself has to be multiplied to both. So that's how I got 7m plus 7. It is equal to, and in this case, 8 times 3, I'm going to call that 24. And then I'm just going to get the 7m by itself, the plus 7, let me move it to the other side as a minus 7. So that gives me that 7m is equal to 17, right? 24 minus 7. Let me divide both sides by 7. Now I'm going to say m is equal to, now 17 divided by 7. I get a calculator and gives me a big decimal. I see it as 2.42857143, right? There's a bunch of numbers. I'm like, wait a minute. I remembered on the instruction that it says rounded to the nearest hundredth. So 2 decimal places. I do take a look at the third decimal place. The third decimal place is an 8, which is big enough. Remember, big enough is 5 or more. So this case, an 8 is big enough. Because it's big enough, the 8 pushes the previous number up. So my answer will be 2.43. Right? If the third number was too small, like too small is 4 or less, then I would have left that as 2.42. But my third decimal place was big enough, so 2.43. All right, let's move on. I'm going to be working up until number 6. Now let's take a look at question number 3, 4, 5, 6. Now here the question are, state if the polygons are similar. Remember 2 criteria that I said. One, same angles. Let me write them down again. The 2 criteria that have to be met is that when it comes to angles, we have to have same angles. When it comes to sides, I have to say sides are proportional. Okay, what does proportional mean? If I have fractions, if I have my figures in fractions, my fractions must simplify to the same thing. If I simplify my fractions, they must simplify to the same thing. If I cross multiply instead, my results have to be equal. Remember question number 1, isn't that what how we solve this? I cross multiplied and I said the results were equal. That's what proportional means. If I had my fractions, imagine I had my fraction 3 over 6, and then I had 8 over 16. Like I said, if I cross multiplied, I get the same thing. 3 times 16 is the same thing as 6 times 8. Right? If I cross multiplied, my result is the same. If I simplify my fractions, notice I get 1/2 on both sides. So again, proportional means when I have my 2 fractions, my fractions must simplify to the same thing or cross multiplied. And when you cross multiply, they must be equal to each other. All right, let's take a look at question number 3 first. Let me take a look at angles. Okay, when it comes to angles, I remember a parallelogram. Parallelogram, 2 angles that were next to each other. So we used to call that adjacent angles, right? Last semester, we used to call that adjacent angles. So 2 angles that are next to each other must add up to 180. So when it comes to the figure on the top, I'm gonna say this angle here at the bottom must be 105 because those 2 angles must add up to 180. Then I look at the second figure. I see 105 here, which is this angle right here. The angles seem to be the same. So I'm going to say this, the first criteria is met. Angles are the same. Now let's take a look at the sides. When it comes to the numbers, on the figure in the top, the numbers that I have are 24 and 16. And then they repeat again. 24 and 16. Okay, let me write them from small to large. So I have a 16 and a 24. Notice I'm going to write fractions. Okay, so notice I wrote both of them on the top. Now my 24, on the other figure, 24 goes with 18. And 16 goes with 12. So there's two ways how I can do this. I can simplify my fractions. They should simplify to the same thing. Or I should cross multiply it, and they should equal the same. They should equal the same thing. If I choose to simplify 16 over 12, let me divide each by 4. That gives me 4 over 3. 24 over 18, let me divide each by 6. That simplifies to 4 over 3. Okay, so yeah, the sides are proportional. Again, I could choose to simplify the fractions. Now, simplifying is not, your forte. It's not what you're really good at. If you prefer to cross multiply it, we could have gone 12 times 24. Right, you guys could use a calculator. 12 times 24 is equal to 288. 16 times 18, I go here, this is equal to 288. So yes, the sides are proportional. Again, in order for me to say they're proportional, I should either simplify and I get the same thing, or I should cross multiply it and I get the same result. So the angles are the same, the sides are proportional, the two criteria have been met. So I'm gonna say yes, this is similar. Remember, the two angles have to be this. That mean the angles, not two, all the angles have to be the same, and sides have to be proportional. Let's take a look at question number 4. When it comes to angles, the top two angles, I see on this figure, they have two arcs, and in this other figure, they have two arcs. Okay, I don't know exactly how big they are, but they're marked the same, so they must be equal. Then the other angles, the bottom angles from the top figure with the bottom angles from the bottom figure, I don't know exactly how big they are, but they're marked the same. So okay, so I'm gonna say the angles are equal. So first criteria has been met. Now when it comes to sides, let me use red so we don't get confused with the top figure. Okay, so I have 3 different numbers. The 9.4 repeats. I have 3 different numbers. So in this case, I have to do 3 fractions. So I'm gonna do 9, 9.4, and 16. Now my 9 goes with 5, 9.4 goes with 4, and 16 goes with 8. Okay, so a couple things I could do. I could cross multiply. The only thing is cross multiplying only does 2 fractions at a time. Okay, only does 2 fractions at a time. So, okay, let's see. Let me check on the, I could simplify, but let me cross multiply. Let me check the first two. Let me see the first two are similar, are proportional. First two fractions. 9 times 4, that's 36. 9.4 times 5. 9.4 times 5 is 47. These are not proportional. I didn't get the same thing. Okay. I don't need to check on the third fraction because as soon as I get the 2 fractions are not proportional. Oh, wait a minute. I didn't put them in order. Remember how I said I had to go in order from small to large? I didn't do it over here. No, I actually did it right. The 9 went with the 5 and the 9.4 goes with the 4. Okay, so I did it right. Okay, so I just found out that they're not proportional. They didn't equal the same thing. Remember, the two criteria have to be met. The angles have to be the same, and the sides have to be proportional. As soon as I fail one of the two criterias, not similar. Good. Let's take a look at number 5. Okay, when I look at the sides, let me take a look at the sides. I have the measurements 12, 7.8, and 18. Okay, let me write them down. I'm just going to write my 12, my 7.8, and my 18. You might be like, hey, Mr. Leonzo, you're not putting them in order. Okay, that's fine. As long as I know which are the proportional measurements on the older figure. My 12 is going to go with 4. My 7.8 is going to go with 2.6. My 18 is going to go with 6. Okay. I could simplify the fractions, or I could cross multiply. Let me cross multiply. Again, the only bad thing with cross multiplication is that I can only do 2 fractions at the same time, not all 3. So when I cross multiply here, 12 times 2.6, I get 31.2. When I go this way, 7.8 times 4, I get 31.2. Okay. So the first 2 fractions are proportional. I cross multiply and I get the same thing. Okay. Let me erase this. Now I had to check the third fraction. I had to check it with one of the previous 2. So I'm going to cross multiply it here. 7.8 times 6 is 46.8. And then 18 times 2.6, that's also 46.8. Okay. So sides are proportional. Notice how I checked. If you look at the angles on the top figure are marked the same way as the angles on the bottom figure. So guess what? These are similar. These two figures are similar. If you would have simplified, 12 over 4 simplifies to 3 over 1. 18 over 6 simplifies to 3 over 1. 7.8 divided by 2.6, it is also 3 over 1. Nice. That could have simplified as well. Okay, let's take a look at number 6. Let me take a look at my figures, the sides. The sides are 30 and 24, and then they repeat again. 30 and 24. 30 goes with 25, and 24 goes with 20. Let me see if these sides are proportional. 30 times 20, 600. 24 times 25 is 600. Okay? Sides are proportional. That's a good thing. Now, when it comes to angles, angles are not equal. Remember, the angles have to be the same and sides have to be proportional. The angles are not equal, so nope, this is not similar.